Good evening, my dear students. So, last class we are talking about the P block elements of group 14. Okay. So, today in this class we will be talking about the group 15. Good evening once again, one and all over there. Okay. Now, I will be talking just to recap what we have done in the last class about the 14 group of elements. So, that is what we have discussed about, basically the general characteristics of group 14, the physical and chemical properties, especially the compounds of group 14. Okay, in that we discussed a majority of the things like compounds of carbon, oxides of carbon, carbides of, and the fuels application of the carbon. Next we discussed about silicon, silicones, silicates. Okay, so then we discussed about silicon and germanium as semiconducting materials, and we discussed about tin and lead. Okay, good evening Vinayak, good evening Josana, Deepak, Samarika. Okay, good evening one and all. Okay, I hope so that is what the topics I will be discussing with you people. Little bit of theory kind of things. I think all of you know that inorganic chemistry is the more about the fact rather than about the logical aspects. Okay. Vinayak Singh is asking, sir, want to ask the questions asked in JEE from this chapter. Yes, definitely. This chapter is once again having 1 to 2 questions minimum. Okay, so that 4-bit questions you can think of. Okay, when we think of in terms of bits, the 4 bits, that is 1 or 2 questions will be there from this chapter. Definitely. Okay. Good evening, Rakesh. That's the reason this is more about fact. That's the reason rather than reading more on this part, what I suggest is you should know how actually the periodic trends occurs in all these things, and you have to know some of the basic concepts like chemical bonding. Okay, the Weisser theory, VBT theory. So, if you know those things apart from the periodic properties like atomic size, ionic size, melting point, boiling points, and some of the facts like diagonal relationship, okay, inert pair effect. If you know those kind of things, so definitely you can answer this type of questions rather than what we call as a continuous reading does not help you out in these classes. Okay, especially in these chapters of inorganic chemistry. If you are able to understand the facts, okay, that is going to help you to answer these kind of questions in JEE as well as in NEET. Okay, so NEET, when it comes to biological application of these metals will be asked usually. Okay, so that is what we are going to discuss as the class goes on. Okay, so anyhow, so today I will be talking about the 15th group, which is also called as 5A group of your periodic table. Okay, before getting into that, let me discuss this is a questions of the last CPP. Okay, so majority of the students went little wrong in choosing the right option. Okay, so I have asked the question which goes like this: which of the following compounds has a peroxide linkage? Okay, so that's where if you look at the year, so this is the P2O, Pb2O3, SiO2, CO2 and PbO2. So now you can think of here the 2 things can be eliminated because silicon as silicon dioxide, as you all of you know that it goes to linear structure. Okay, so when it goes for, when you calculate the oxidation number also, they are not going to have peroxide. So that is only one compound which you find is the PbO2. Okay, so that makes Pb2 plus, okay, plus O2, okay, 2 minus. So this gives us a peroxide linkage rather than any of these compounds. So that's what very clearly JEE, that's what you can think of little structure based. Okay, you can answer these kind of questions. I hope you understood this, and the option A is the D, which is the lead oxide. Okay, which has a peroxide linkage. Now for today's goal for the class. Okay, good evening Mansi. Okay, Nikhil Chaudhary, Rakesh, good evening once again. Okay, so today we will be talking about the general characteristics of group 15, or this is also called as 5A in the Hold nomenclature method. So where we will be talking about general characteristics like physical character and some of the chemical characters which are exhibited by majority of the compounds which we find, that is 5 numbers of this compound in this particular group. Then we will talk about more on especially the nitrogen and oxides of nitrogen. You all of you know that nitrogen have a majority of oxides. Similarly, the phosphorus and its oxides. This finds lot of applications because we find a n number of compounds are obtained because of these two elements compared to the rest of the elements of the group. Okay. So now we will move on to the general characters or how the 15 groups gets into this one picture. So now you all of you see on the screen. So this 15 group of elements, the nitrogen, phosphorus, arsenic, antimony and bismuth. So these are the group of elements which belongs to 15A. So when we look into that, okay, when we think of, I think Shubham is asking about what is the difference between the peroxides and superoxides. The peroxides will have one charge, superoxides will have two negative charge on the oxygen atom. That's what the difference between peroxides and superoxides. That's what if you look at hydrogen peroxide. So that is one best example. K2O is the superoxide, where you can find the differences between which we are discussed also in the case of hydrogen as well as earlier in the case of what we call as alkali metals. Okay, I hope Shubham you got the answer for that. Okay, Rishabh, good evening. So now if you look for these elements, that nitrogen, phosphorus, arsenic, antimony, okay, not AUNTY, this is ANTI, okay, that is what carefully, antimony and the bismuth. The atomic numbers are also given over there and the mass numbers which goes as. And if you look at the electronic configuration carefully, so in all these cases, the outermost electron goes to the p orbital, and if you observe carefully compared to the 14 group of elements where they are not off filled exactly. Now if you carefully observe here, all the electronic configuration of the p orbital are exactly off filled. So this makes a special character and extra stability for all these elements, especially when you look at nitrogen, it in the free state or in the neutral state, it is the most stable, okay, molecule. Okay. So next, coming to the radius, covalent radius, okay, 75, 110, 121, 140, as we go down the group, as it shows it, there is an increase. So coming to ionization enthalpies of the first ionization enthalpies, okay, off filled configuration, yes, that's what they are called as exactly off filled configuration. This is when we have degenerate orbitals. So the orbitals which gets 0 off filled, that is exactly to that total number of electrons, are completely filled. They show extra stability. Okay. So that is what we have studied when we discussed about the periodic table. Okay. So that is what if you look at carefully. And coming to electronegativity, all of you know that that is decreases down the group. Okay, whereas the nitrogen is having exceptionally high in compared to all of its. So what may be the reason for this? This is basically with respect to their sizes which we talk about. And coming to the first ionization energy of nitrogen, as well as if you look at for other elements of first ionization energy, which as we go down the group that decreases. Once again, that is basically with respect to, so which I want to tell about the size of the atom. So coming to the common physical forms, that what we talk about, the colorless, white solid or red solid, this is phosphorus. That's what we talk about the later in the classes of this today's. So we will talk about that's what I will talk to that. Mohan Chaitanya is asking, sir, why they are called as pinicotins. Okay, that I will tell you, because next group is the chalcogens. Okay, so that's the reason these are before that. So hence they are called as pinicogens, and the compounds are called as pinicotosides. Okay, tides. So that's what I am talking about. These two are called because they are prior to the next group of elements where they are called as chalcogens. Okay. So that's the reason, and you can find majority of once again the phosphate salts which are available. So that's the reason they are called as the phosphorus and its compounds. Okay, that's why they are called as what we called as pinicogens as well as pinotosides are the compounds which are formed by this group of elements. They are called as pinotosides. Okay, I hope you got the answer for that. So next, when we looked into some of the common physical forms, they are arsenic is yellow solid or grey. So that I will be talking about when it comes to what we called as allotropic forms of these. Okay. Coming to atomic radii, as already said, if you remember the atomic sizes here, 75, 110, 121, 140 and 155. So down the group, as you know, okay, it keeps increasing. Okay. So that is what you have to remember, because the added electron will enter to the new shell, and because of the new periods are going to be existing in them. So that makes them to increase in size. Because of that, as we go for here, the arsenic, okay, the first two which we are talking about are the non-metals. Another two are metalloids, and the last one is the metal. So when you think of this, the what we call as arsenic and antimony, there is involvement of your d orbital takes place, okay, 3d series and 4d series, which makes the screening of electrons, okay, that's the reason the size increases suddenly, okay. So when you look for the bismuth, once again the f orbital comes into picture, because of the still the screening effect will be more, hence automatically the effective nuclear charge decreases for the outermost electron, thereby the size of that atom increases a larger, okay. So almost we can see the first element what you are seeing is 75 picometers. When we look for the bismuth, it is almost double, okay, of in picometers. So coming to electronegativity, as I already said, this is due to the size, okay, that's where so we talk about. So coming to the ionization energy, once again if you go back, you can see over here the ionization energy of this nitrogen is very high because of p pi bonding between the nitrogen atom and nitrogen atom. So that makes anomalous property for nitrogen, so which gives extra stability because of off field things. That's the reason ionization energy also little higher when compared to the 14th group of elements, because I cannot compare with the periods. So just I can compare with the group. This is the 15th group. When I look for the 14th group compared to that, so they are having high ionization energy, because as we move from left to right of the periodic table, you can see the size of the atom decreases. So that is also one of the reason, and apart from that, the off field orbitals will make this stability for these molecules, okay. So now we move towards the oxidation states. When we look for the oxidation state of these compounds, they will vary from the oxidation state of, if we talk about nitrogen, it will start from -3 to +5, -3 to +5 oxidation state will be shown, okay. So if I talk about the best example for +1 oxidation state of nitrous oxide, that is N2, okay, you can see that N2O5, okay, where you can find the +5 oxidation state, okay, +5 oxidation state. So then we go for +4 oxidation state, where you can find N2O4. So this is the molecule which shows +4. When we go to +3 oxidation state, we can find N2O3. +2 oxidation state you can find with NO, and +1 you can find with the N2O, and 0 oxidation state you can find with N2. So as we move to the other molecules, that is negative side of this oxidation, so the negative oxidation state is like -1, so will be shown by NH2OH, okay. So then it is shown by hydrazine, the -2 oxidation state for nitrogen. When you look for NH2NH2, so this is the one important compound which is called as hydrazine. So then we are having another compound in the -3 state, so where we can find NH3, okay, Mg and N2, okay. So this is where you can find the nitrogen in -3 state, okay. So now when we think of these compounds, there are n number of properties can be identified. So that is the oxidation state of this, and majority as we go down the group, this oxidation state will be reduced in the nature. So because once again the D block comes into picture, that's the reason you can find the maximum is -3 to +1 in that conditions, okay. So that is what the thing which occurs. So coming to the self-linking property, that is what is called as catenation, which we discussed in the last class also. When you think of this, this is where the nitrogen is going to exhibit, but not as in the case of the group of what we think of the group 14, like carbon. Carbon is going to have n number of linkage, whereas in the case of this, so we cannot expect more compound. That's what it can form. The maximum charge is, so that's what, sorry, so that is N3 minus. This is called as azide ion. So this azide can go to maximum 3. So that makes the catenation property. As we go down the group, the catenation property or self-linking property decreases. So this is because of the increase in size as well as the electronegativity of the compounds, okay. So I hope you got the things. So coming to the next is oxidation state. So before getting into oxidation state, let me talk about some properties called as allotropic forms. Okay, these are also comes under physical properties. When we think of allotropic forms, so majority of the compounds, majority of these compounds of this exhibit except bismuth. Bismuth is a metal, it is not having any allotropic forms, but when it comes to the nitrogen, it exists in two forms. So that's what when we think of the solid nitrogen exists in two forms. So one is called as orthonitrogen, okay, nitrogen in solid state I am talking about, okay. So it is having a orthonitrogen. So and another is which we can expect is beta nitrogen, okay. So nitrogen form. With this alpha nitrogen basically goes with respect to cubic crystalline packing. So when it goes for the beta form, beta nitrogen, which is having hexagonal cubic form. Okay, so these are the things which is exhibit. So coming to the phosphorus, phosphorus exists in several allotropic forms, namely like white form, red forms, okay, and it is exists scatolate form and alpha black, beta black, and as well as a violet. So these are the different forms. H3NH3, Deepak is asking N3H3. So when you think for this, okay, so this is what you are asking, N3H3, this is highly unstable compound, okay, there is highly unstable compound. That's the reason it forms, but is not going to kept at room temperature. It is highly unstable molecule. It decomposes to give ammonia and as well as hydrogen molecule. Okay, so that's the reason this N3H3 it is very difficult to store and it cannot be existing at room temperature. Nikhil is asking what is this allotropy. Allotropy is nothing but so existence of the compound in different physical states, but they have the same chemical composition. That's where so we think of we call them as allotropes. Okay, so coming to the what we call as the next allotropic form of arsenic. Arsenic exists once again three form. One is grey, yellow, as well as the black. Antimony exists in three form. One is called as metallic antimony, yellow antimony, and explosive antimonies. Okay, Tamanna is answering for that. Yes, the same thing which I said, the physical forms are different, but the chemical composition remains same. Okay, so now coming to the next part of this what we call as oxides, the physical states. After this we have to discuss about the chemical properties. When we talk about chemical properties, you all of you know that the halides of these compounds are more important, because when we think of your PCl3, NCl3, okay, PCl5, okay, these are the compounds which are very much used in the chlorination and Friedel-Crafts reaction. I think you all of you know that. So that's the reason. So these compounds exist. That means halides in the form of trihalides as well as pentahalides are possible, but pentahalide of NCl5 is not possible, only PCl5 is possible. So this is because remember the D block orbitals are not available for nitrogen, hence it cannot extend its covalency, whereas in the case of phosphorus it exhibits the D orbitals, thereby it can extend its covalency, thereby you can find the PCl5 exists, whereas NCl5 does not exist. So this is what the most important thing which you have to remember over here. So coming to that properties of these trihalides, I think you all of you know that basically chemical properties which I am talking about, these trihalides, they undergo hydrolysis very easily. So that's what if you think of NCl3 when it is treated with water, okay, so it gives you ammonia and hypochlorous acid, HOCl, okay. So this is the compound. Or if I treat with PCl3 plus water, okay, so then you find the 3HCl molecule plus the H3PO3, that means phosphoric acid. Okay, so these are the components. That means we can use this for obtaining inorganic acids. So that is one of the best application of these compounds. So when we think of your PCl5, okay, it is similarly that. I think all of you know that PCl3 and PCl5, if you look for what we call as haloalkane preparations, they find lot of applications. So that's the reason PCl3, PCl5, when it treated with alcohol, so they are going to convert into haloalkanes. Similarly, thionyl chloride is also used, one of the component. Okay, so these are the things which I am going to talk about. Next is if you look at the stability of PCl5, what we think is it going to exist in the form of PCl3 with the Cl2. So this is what the stability, where you can find equilibrium between the trichloride, the thihalide with the chlorine molecule. When it is highly instability, because it is more effective in chlorinating agent. When we look for the X-ray studies, okay, so this compound, the PCl5 which you are finding, is an ionic compound in the solid state. Okay, this may be your important question. Okay, remember the PCl5 in the solid state, it exists as ionic compound. So due to that, when you look at the structure in the X-ray diffraction study, this exhibits, okay, PCl4, okay, having a positive charge with respect to PCl6 with negative charge. So that means this undergoes dimerization in ionic form. So that is the beauty of this compound. Okay, so look at this, PCl5 in the solid state exists as ionic compound, and on X-ray diffraction study you can find PCl4 plus and PCl6 minus, which is shows the dimeric nature. So this is what the X-ray studies which we talk about. Coming to the oxides of nitrogen, before getting into oxides of nitrogen, let us look for what actually the anomalous properties of this nitrogen. So when we look for the anomalous properties of this nitrogen, okay, all of you know that it exhibits, first is the small size. So this is the very important. The second thing is high value of electronegativity, high value of electronegativity. Okay, the next which we talk about, non-availability of d block elements, orbitals, d block orbitals or valence shells, d valence shells. Okay, the next is ease of multiple bond formation. That is what is very important. Ease of multiple bond formation. Deepak is asking something about PCl4 and PCl5 charge. PCl5 is, Vinayak is asking, yes, let me tell. See, when you take the PCl5, it is highly reactive compound, it is used as a chlorinating agent especially. Okay, so that's the reason if you think of an alcohol, ROH, okay, I want to convert into an haloalkane. Okay, so then you can think of this PCl. Somebody is telling water treatment, so sorry, PCl5 is highly reactive, it catches the fire, we cannot put into water. Tamanna, please, okay, don't put that one, you will get fired up. Okay, so that's what it is used as a chlorinating agent especially. We can prepare what we call as hypochlorous acid, that can be used further. Okay, but directly PCl5 cannot be treated to water, it catches the fire. Okay, it is stored in dry condition, okay, and in manufacturing of pesticides, that is true. Okay, but in the especially in the chlorinating agent, that is alcohol we are taken, and when you treat with the PCl5, you can expect RCl. Okay, then you can expect POCl3 plus HCl. Okay, so this is the one molecule where this is called as haloalkanes. Okay, that can be obtained. Haloalkanes are very much used in drug industries, especially the syrups which we use as a cough syrups. Those comes with respect to halides of these compounds. Okay, there it finds application. PCl5, please don't add to water, it catches the fire immediately. It is highly reactive component. That's the reason this should be stored at a very low temperature in what we call as the dry atmosphere. We have to use this. Okay. Even phosphorus, uses of phosphorus are so many are there. When I am coming to the next few slides, I will be talking about them. Okay. So that's why this basically used as a chlorinating agent. Okay. So next, these are the things which you have to remember. That is what we called as oxides of nitrogen. That is, before going to that, the what we called as anomalous properties of this nitrogen. Once we know this, then you can find n compounds of this nitrogen. The first compound of nitrogen goes like this. So I think all of you know that the first compound of nitrogen, okay, is the N2. That's what I am talking about, dinitrogen, okay, which occurs in the nature about 75% by weight, okay, or if you considering in terms of volume, so this goes about 80% in air. Okay, this is exist in free state. Okay, that is where we talk about when we think of the existence of these compounds, they exist freely in the nature. Okay, that's where it is in the combined form. It exists in the form of nitrites as well as nitrates, ITEs and 8s. Okay, that is what you can find, and it finds as much as in the case of as an essential components. Okay, essential components of all proteins and found in animals as well as and plants. So now you know what is the importance of this nitrogen. Nitrogen plays at almost all plants and animals, because so this is one of the important component of your, even if you think of your purine and pyrimidine bases of the DNA, there also you can find the nitrogen group. Okay, so that's what nitrogen plays a very, very important role. Coming to the properties of the nitrogen, nitrogen is a colorless, okay, tasteless gas, and it is a odorless gas. It is lighter than air. Okay, that's the reason these nowadays we are using them in the what we called as nitrogen air fillers for your vehicles in the tires. Okay, so that it creates less friction, so that the mileage can be improved. That is the one thing. And even the gets puncture also, so vehicle can that it can avoid what we call as immediate loss of the air and the flattening of your rubber tube. So that's the reason. So this is used in these cases. Okay. So next element which we talk about is the compound of that is nitric oxide. Okay, nitric oxide. I think you all of you know this. This is called as, okay. So this is where I am going to talk about nitrous acid. Sorry, nitric acid I will talk about later. Nitrous oxide I will be talking about first. So which is called as N2O. So which is, I think you all of you know that, you may be laughing now. Okay, so that is called as the laughing gas. Okay, so this is called as the laughing gas, which is prepared in the laboratory just by taking ammonium nitrate NH4NO3 when it heated. So it forms N2O plus water, and this is highly unstable. Immediately it combines with oxygen to form dinitrogen dioxide. Okay, nitrogen dioxide. It is nitrous acid is a colorless neutral gas with a faint pleasant smell, and it is heavier. Okay, and it is fairly soluble in water but not in hot water. Okay, so it is poisonous in nature when is inhaled, because it is causes a special disease called as laughing hysteria. Okay, hysteria of laughing or laughter, what we call as, that means the person will be continuously laughing, and because of that, so it creates a loss of hysteric. That's hence the reason this is called as laughing gas. Okay, so the next compound is the nitric oxide, which I was talking about. Okay, the nitric oxide. Okay, when we talk about nitric oxide, that is nothing but NO. Yes. Okay, nitric oxide, once again this whenever you treat what we called as copper, okay, So that is copper when you treat it with HNO3 in the laboratory. So you will get a cupric nitrate NO3, okay, twice plus 2NO. This is a reddish brown fumes, okay, which are going to be obtained. Immediately this is also highly unstable, and immediately it converts into NO2, that is nitrogen dioxide, okay. So the properties, coming to the properties of nitric oxide, is once again a colorless, slightly heavier than air, okay, and it is liquefied with a great difficulty and high pressure and low temperatures, okay. So this it is paramagnetic, okay, because of presence of unpaired electrons in the molecule, okay. That is what you have to remember. They may ask you, so NO, whether it is a paramagnetic or diamagnetic, if you want to identify, so you have to find out the unpaired electrons. Thereby when you look at the molecule bonding and number of electrons, so we can find the unpaired electron, thereby it acts as paramagnetic in nature. Ansraj is asking something, under suitable condition it should be prepared at what temperature and what pressure, okay. This has to be done only in inert atmosphere. Any temperature you can use it, it is not a problem, only the purification problem comes, that is the reason. So by Oswald process nitric acid you are synthesizing, I am not talking about that. When you want to have a laughing gas, you can obtain in the laboratory, okay. The only the thing is it should be free from air, so that it should not get converted into nitrogen dioxide, that is the only reason, okay. That means inert atmosphere you have to do this, okay. I think you got the thing. So next compound which I will be talking about is dinitrogen dioxide, okay. What we called as the structure of this NO, okay. So let me talk about a little structure, why it is paramagnetic also. So when you look for this, you can find here, so 2 electrons, the unpaired electrons over here, so thereby you can find here 3, okay. When you find one unpaired electron over here in the molecule, so that makes us to get into paramagnetic nature, okay. So I hope you got this. Next is nitrogen dioxide, so which is once again, you all of you know that very dangerous compound NO2, but it is very helpful in some of the biological system, where we called as endothelium nitric oxide synthase, an enzyme which will make us to get what we called as proper contraction of the blood vessels, so that it will avoid the what we call as heart attack and other things, because endothelium nitric oxide has to be there, so that the blood vessels can contract and expand normally, okay. So now coming to the nitrogen dioxide, okay, it is a reddish brown gas and exists at room temperature and at also very low temperature. It dimerizes to nitrogen dioxide, okay, that tetroxide, so that NO2 dimerizes with NO, okay, it forms okay N2O4. So this dimerization takes place, and this is what we called as, so because of non-availability of free electrons, it becomes diamagnetic in nature. So before getting into some of the properties of these compound, so we will look into what we called as the last previous contest question, okay. The previous contest question was at high pressures the van der Waals equation becomes, these are the options they are given, and the winner is Kanishk. I congratulate Kanishk for one atom session of will add to your account. So the today's contest question goes like this: which of the following is the tetrabasic acid, okay. So which of the following is tetrabasic acid, okay. So that options are given: orthophosphoric acid, orthophosphorus acid, metaphosphoric acid, as well as pyrophosphoric acid. Okay, I hope I think you have done the things. Your time goes now. Countdown start. 5, 4, 3, 2, 1. I think you all of you done. Okay, I think Deepak was asking some question regarding what we called as N2O4. Okay, so that's what NO2, when you are getting in a room temperature, that NO2 molecule undergo dimerization. So it joins together to form N2O4. So let me give the structure of your nitrogen dioxide first. So this is one dative bond where lone pair of electrons will be there. So then you can find electrons over here and another oxygen atom here. So this gets with a lone pair of electron here. Okay. So this can exchange with the resonance structure. Now one more nitrogen combines, that is NO2 combines with this of similar this. Okay, that's where you can find. I will give the structure for that, double bond O. So your lone pair of electrons and dative bond of this. Okay, where you can find the electrons, then you can find electrons over here. Now this linking, if it is occurs, that means if it is undergo dimerization, there is a bond formation between N to N takes place. So thereby, so I look for the structure of this dimerized N2O4, okay, dinitrogen tetroxide, that will go as the N will be there and one more N. So then you find a dative bond of oxygen over with nitrogen, okay, where you can find the electrons. Similarly, oxygen over here, and you can find as 6 electrons over here. Then you find a double bond oxygen for this nitrogen also. There you can find the 4 electrons on this. So now this the distance between this is 1.75 angstrom. Okay. So now this is the structure of your what we called as N2O4. Somebody was asking, so how, what is this N2O4? N2O4 kya hai? So N2O4 is nothing but nitrogen tetroxide. Okay, that is obtained only when dinitrogen dioxide get dimerizes. Okay. So next is the last component of this is N2. Okay, N2O5. So when we think of N2O5, this structure goes like this. So N2O5, nitrogen pentoxide. So this decomposes on eating to form 2N2O4 plus O2. Okay. So this is once again a source of good oxygen. Okay, oxygen molecule. How do you obtain this? So this is obtained like this. This is when nitric acid, okay, HNO3, okay, heated in presence of P2O5, phosphorus pentoxide. So this is going to form N2O5 plus H2O. So if you look at the number of nitrogen has to be balanced. Thereby, if you take 2 here, I think you can check out everything is balanced. So this is the way we can prepare nitrogen pentoxide. Okay, and coming to the structure of nitrogen pentoxide. So there is a bridge oxygen between the 2 nitrogen atom when compared to your N2O4. So this remains similar in structure except the bridged oxygen between the 2 nitrogen groups. Okay, so this is a small change when compared to N2O4 is considered. Okay, I hope you got the concept here. So coming to oxides of nitrogen, you have n number of oxy acids. Okay, so that is one is if I want to talk about first one, so this is called as H2N2O2. Okay, so this is or this can also be represented as HNO. So this is called as hyponitrous acid. Okay, hyponitrous acid. Next is hydroxynitrous acid or oxalic acid. Okay, which is nothing but H4N2O4. Okay, or which is can be represented as H2NO2. So then is next is nitrous acid, which is nothing but HNO2. I think you all of you know that this is very much useful in a diazotation reaction. Okay, or primary amine where converted into alcohols. There we use nitrous acid and pernitrous acid. Okay, that is pernitrous acid goes like this. So which is nothing but HOONO. Okay, where the oxidation state of nitrogen is +5. So that is one important. And next is, I think all of you know, very commonly used nitric acid nitrating agent, which is used HNO3. So in this case you can find once again the +5 oxidation state of nitrogen and pernitric acid. So pernitric acid. So this is another compound HNO4. Once again it is highly unstable. So this goes for +7 oxidation state. This is unusual oxidation state. So that's the reason we are this is highly unstable molecule and used as a good nitrating agent. So these are all about when we think of your what we call as nitrous oxides of nitrogen. Next I will move towards the phosphorus and its compound. So phosphorus, I think you know that ammonia I didn't discuss, because ammonia, all of you know that this is manufactured by Haber's process, and the nitric acid which is also obtained from Ostwald's process. I think you have studied those things. So that is the reason I didn't discuss about those things, but so we will be talking about the next compound called as the phosphorus. The phosphorus basically exists extremely in active element and occurs only in the form, in the combined form. It is not exist in the native form. Okay, so especially the phosphate form, okay, and phosphorite form and apatite form or fluoroapatite, which we call it as. Okay, phosphorite, which the name goes, the one of the source for your phosphorus, which I call it as calcium PO4 twice. Okay, and chloroapatite. Okay, this is another ore for this calcium, that is 3Ca3 PO4 twice CaCl2. Okay, so this is another compound, or we can get from apatite. Okay, APTITE. So where you can find Ca3, so PO4 twice dot CaF2. Okay, so these are the oles. This may be a question for you people. Okay, so just you know this where the sources of phosphorus, and you know that phosphorus exists in the tetrahedral form. So that is where the phosphorus goes like over like this. These are the structure for phosphorus. It goes like this. Okay, so then bond angle, when you think of your, so the 60° will be there. When you think for your lone pair of electrons will be there, your lone pair of electrons, your lone pair, so your lone pair, and the distance between this is 2.1 angstrom. Okay, coming to the phosphorus compounds, the basically when you think of pH3 is one of the best phosphorus phosphine, which we call it as PHOS, So this is obtained when phosphorus is treated with hydrogen molecule. Okay, so this is very important component for majority of chemicals, especially in the case of doping of silicon. So this pH3 is basically used. Okay, next the points of resemblance of ammonia and with phosphine, because when you look for pH3, similarly NH3 is also there. So now when you look at this, as we go down the group, hydrates of these groups, the bond angle decreases. That is because of lone pair and converting into the big size of the molecule also. Yeah, that is what we call as increases. Thereby electronegativity decreases. That makes the bond angle to decrease down the group with respect to what we call as ammonia, phosphine, or what we call as antimony hydrate, bismuth hydrate. Bismuth hydrate is very less phosphine. Okay, but when we look for the resemblance of the point, both are colorless and heavier and similar chemical formula. That is what you can see over there, and both are combustible in presence of oxygen. That is very important. Both decomposes into their constituent elements, passing a high electric field. Okay, so when you pass electric shock to that means it get converted into respective elemental thing. Both react with chlorine violently. That is what more important with respect to these components. The next is phosphorus tetroxide, that is what P2O4. So this is oxides of phosphorus I am talking about. So this is one compound P2O4, or this is also represented as P4O8. That is once again you can think of dimerization exhibits. Phosphorus pentoxide is also possible, that is P2O5, so which is also once again a compound. Or when you look for this, so this in dimeric state it forms P4O10. Okay, so that is where this is represented once again. So both oxides are dimeric in nature. That is what you have to remember over here. So if we want to the structure of these phosphorus oxides, okay, just very difficult to represent. Let me write one structure for all this. It goes like this: phosphorus over here and oxygen comes over here. So then one more phosphorus, then oxygen. Okay, one more phosphorus over here. So then it goes with the oxygen. So now if you carefully observe, this phosphorus to this oxygen linkage will be there, and this phosphorus to this you can find one oxygen bridge will be there. Okay, when you look for the angle of this is goes to as 120 degrees centigrade, 120 degrees, and it goes as 100 degrees, as well as this length between the phosphorus and oxygen is 166 picometer. Okay, this is phosphorus trioxide when you think of in dimeric states. So now when we think of the pyrophosphoric acid, especially the acid which gets very important applications in majority of what we called as medical applications and protein precipitation. That's what it is, a tetrabasic acid, okay, which is obtained from the sodium what we call as Na2P4O7, Na2P4O7 on decomposition. So that will give us what we call as HPO3, the phosphoric acid. Okay, so that is a one important compound of your phosphorus. So when we think of the oxides of phosphorus, you can find n number of compounds. So that is where it goes like this. The first compound goes for as H3PO4. So this is very important. I think all of you know that this is a phosphoric acid, or orthophosphoric acid is kept as, which is a tribasic acid. So the structure goes like this, because structures are more important in this part for your board exam as well as your JET to identify the tribasic or tetrabasic acid. You can, if you write the structure, then you can easily identify, because 3 hydrogens can be easily replaced, thereby this is called as a tribasic acid. So similarly, if I go for HPO3, okay, it is a monobasic acid, so which is called as metaphosphoric acid. Okay, this is called as metaphosphoric acid. The structure goes like this. So P double bond O, whereas OH will be there. So this is a metaphosphoric acid, because only one replaceable hydrogen, then it becomes monobasic acid of this. So if you think of dibasic acid, so the dibasic acid is H3PO, once again 3, which you look at, the P goes with OH here and the OH on other side, and the H is directly linked over here, and look at here carefully. So this H3PO phosphorus acid is called as a dibasic, because only 2 replaceable hydrogen, whereas the other hydrogen, even though it is present, it is not present with respect O, it is directly linked to the P, thereby the dissociation or the breaking of bond is very difficult. Okay, so that's the reason it will be called as dibasic acids. So now I hope I think you understood what I discussed about the oxides of phosphorus. So now, so just to come to the end of the class, okay, the today's class what we discussed is general characteristic of 15, physical and chemical, and compounds of group 15, that's what nitrogen and oxides of nitrogen, phosphorus and oxides of nitrogen. Okay, thank you for joining HashLearn. Okay, I hope after my class you have a CPP question. I think passport you have to log in immediately and answer all the questions. Okay, all the best.